Okay, question number 7. Let I be the moment of inertia of a uniform square plate about an axis AB that passes through its center and is parallel to two of its sides, these two sides. So I draw the axis. This is the axis. Okay, the axis, this axis is called, this axis is going to be called AB. So axis is AB. So what is the moment of inertia? I'm repeating, the moment of I is the moment of inertia of a uniform square plate about AB that passes through its center and parallel to two of its sides, parallels to two of its sides. CD is a line in the plane of the plate that passes through center of the plates and makes an angle theta. So there is another line that is passing through the center and it is making what? This line they call it CD. This line they are calling it by the name CD, and it is making an angle theta. Okay, I'm repeating. What is the question? You have a square plate. I'll illustrate the question. You have a square plate, uniform square plate, and I take one axis AB, which is parallel to the sides, parallel to two sides. Okay, and then there is moment of inertia about AB. IAB, they call it by the name I. Okay, they call it by the name I. And then what about moment of inertia about CD? There is another axis at an angle theta. So you have to find the moment of inertia about that axis. I'll tell you. Look at this. Hope you remember perpendicular axis theorem, and it was done for a square plate. Do you remember this? I'll just draw this. So I have a square plate here. What is the moment of inertia of this square? I just imagine this axis is 1, this axis is 2. This is 1, this is 2. Okay. And what is the moment of inertia about Z axis? This one I call X axis. This is Y axis. What is the moment of inertia about this one? Do you remember perpendicular axis theorem? According to perpendicular axis theorem, IZ is equal to IX plus IY. Just imagine. See this. This is a lamina, no? Lamina. Okay. The lamina has an x-axis. This is x-axis and this is y-axis. So when you hold it along x-axis and rotate, the moment of inertia is Ix. And hold it on y-axis and then rotate, moment of inertia is Iy. And when you add them up, what you are getting is moment of inertia about z-axis. Z-axis perpendicular to it, no? So we have learned the theory, Iz is equal to Ix plus Iy. Moment of inertia above z-axis. Look at the z-axis, it is coming out of the board. It's coming out of the board. No, I'm not drawing it. Is Ix plus Iy. So I could write this Iz. Iz is what? Iz is Ix, that is I1 plus Iy. Ix is I2, Iy is I1. So I1 plus I2. Okay, I1 plus I2. But I1 and I2 are same, no? Because by symmetry, this line and this line, they look the same, right? So I could write I1 and I2 to be same. I1 is equal to I2. I1 is equal to I2. So what do I get? Iz is equal to, for I1, I'm putting I2. So I2. I1 is equal to I2, no? So I2 plus I2, 2I2. That is my first equation. All right, this axis is 1. I take another pair of perpendicular axes. Look at this one diagonal here. Look at this one diagonal here. One diagonal here. Right. One diagonal. And one diagonal here. I'm calling them 3 and 4. They are also perpendicular. See this? They are perpendicular to each other, no? So I can apply perpendicular axis theorem one more time. Perpendicular axis theorem one more time. This axis, about this axis, no? What is the moment of inertia? Iz is equal to what? It is I1 plus I2, but it is still I3 plus I4. It is equal to I3 plus I4. And look at these diagonals. These are diagonals. And as far as the square is concerned, both the diagonals are identical, which means I3 is equal to I4. So I3 is equal to I4. Both are diagonals, no? So moment of inertia about the diagonal is the same, right? Whichever be the diagonal. So I can put in place of I3, I can put I4. So Iz will be equal to what? This is I4 plus this is I4, and that makes it Iz is equal to I4 plus I4, 2I4. Okay. So from this, I got Iz is equal to 2I4. From this, I got Iz is equal to 2I2. So I can equate them. Both are IZ. Left side is IZ, left side is IZ. So right sides are equal. So 2I2 is equal to 2I4. So if I cut it on either side, the 2, I get what? I2 is equal to I4. Okay. I2 is equal to I4, but I2 is already equal to I1. Similarly, I4 is already equal to I3. Okay. I2 is equal to I1. So I2 is equal to I1 is equal to I1, right? And I4 is equal to I3. I4 is equal to I3. That means moment of inertia of this lamina about any axis would be the same. Understand? About any axis. And you learn this as a result for a regular lamina, for a circle, even for a circular lamina, about this axis and about this axis. Theta, this angle is theta, would be the same. Check your notes, it is there. Okay, we have written this. This angle and this angle, we have written this. The angle between them is theta, and the moment of inertia about this axis is same as moment of inertia about this axis, is same as moment of inertia about this axis, same as moment of inertia about this axis, same as moment of inertia about this axis. So in the plane of the lamina, whichever axis you take, the moment of inertia will be the same. That is applicable here also. Moment of inertia about this one would be same as what? Moment of inertia about this one would be same as what? Even if the axis is at an angle theta, that would still be the same. Okay, if you take a third angle, still the moment of inertia is same. Understand? So on the plane of the lamina, whichever, look at this. This is the square lamina. Just imagine this is square lamina. It is rotating about this axis. It is rotating about, sorry, it is rotating about this axis. No, this axis, right? It is rotating about this axis. It is rotating about this axis. Whichever axis it is rotating about, understand? The final answer is what? Moment of inertia will be the same for all guys. So the answer is option A. See this? It's such a simple question as the previous IIT JEE question. Did you understand this?